So a transformation is a mapping, well, basically a rule that moves or changes a figure to produce a new figure called the image. So the original figure would be your object. The new figure would be your image, object image, right? So we go in. We have four types of transformations, right? Reflection, translation, which is like a slide, enlargement, and then rotation. So reflection is a transformation that produces a mirror image of a figure in a line. So when you're writing out a reflection, you have to use the word in. So it's a reflection in the line, whatever it is, right? A translation is a transformation that moves every point of a figure in the same distance in the same direction. So now we have enlargement. This is a transformation that changes the size of a figure by a scale factor. See that word scale factor? Very, very important, right? By a scale factor from a fixed position called the center of enlargement. So these are the two most important things when you're dealing with an enlargement, right? So a rotation basically turns a figure about a fixed point called the center of rotation, very important, through a given angle and direction. So direction being clockwise or anti-clockwise. Symmetry. When a shape has symmetry or a line of symmetry, a shape has symmetry if there is a line such that when the shape is folded, both halves match exactly. Basically, that line of symmetry does cut any shape in equal parts, two equal parts, right? Then rotational symmetry. What rotational symmetry means is that think of like a square, right? If you turn a square this way and it will look the same, if you turn a square this way and it will look the same, right? So rotational symmetry, a shape has rotational symmetry if it can be turned about a fixed point, which will be the center, right? And you're not making a complete 360, but the shape could look exactly the same. So that is what, like a 90-degree shift, right? And the square will still look the same. You shift 180, it will still look the same. That is rotational symmetry. The box below contains the name of 5 quadrilateral. A quadrilateral has how many sides? Everybody knows that, right? 4 sides. So we have a trapezium, a rhombus, a kite, a square, and a rectangle. Trapezium has 2 parallel lines and 2 sides that are not parallel, right? And then a rhombus would be 4 equal sides, right? But it's not necessarily 4 90-degree angles, right? And then a square and a rectangle, everybody's supposed to know what these things look like, right? So there we go. Choose the name of one quadrilateral from the box that best completes each statement. So, a what has no lines of symmetry and has rotational symmetry of order 1. No lines of symmetry here. So this will be a trapezium. A what has exactly 2 lines of symmetry and 4 right angles. Dog food, what's that? Right? A rectangle. So let me put that in. Rectangle. A kite has 1 line of symmetry. So the triangle x prime, y prime, z prime is the image of triangle x, y, z after an enlargement of scale factor 2, right? So this is actually the image after an enlargement, right? With center 5, 1. So the first thing I want you all to do is locate the center 5, 1. So my center would be here. Locate your center. This is your center of enlargement. Okay? And this is how it works. Stay with me, right? Let me use red lines. So you're going to draw a line from the center of enlargement to all the corresponding points, right? So that's 1. So draw a line from the center of enlargement to every single vertice in the triangle x prime, y prime, z prime, right? Your center of enlargement is like where the beam of enlargement coming from, right? Now, this is the already enlarged image. So we want to come back to the original image, right? So sorry, this is the image. We want to come back to the object. So look at how it works. They said it was enlarged by a scale factor of 2. So that means that if this line from here to here is 2 centimeters, right? It means that the object would be 2 divided by 2, which will be 1. So we're looking for a distance between this line here and this line here, 2 coordinates where the distance is actually 1. So make sure you all can locate it on your page, because I can locate it between here and here. You all see how it says just 1 centimeter apart? Nowhere else is there a distance of 1 centimeter apart between these two lines. Everybody seen that? So that there would be the line X to Y. So let me draw that. This will be X to Y. Boom. X to Y. So Z would be 2 centimeters down here. Okay? And then you just complete your triangle. So this is my object. So I'll put O. This is the object. This is the image. If I want to plot this point here, right? What do? I look at the point, well, the coordinate on the x-axis, which is -3. I come up exactly on that line, and I make sure it lines up with the 3 on the y-axis. That's where my coordinate would be. Plot that point. Then you have -3, same -3 for this point up here, and then it will be 7. That's how you track the point, right? So that will be -3, comma 7. This is where the point is, right? Next point, which is this point here, that will be -1, comma 7. So this will be 7, comma 3. This will be 7, comma 7, right? And this will be 5, comma 7. This one, right? So part 2, the triangle x prime, y prime, z prime is mapped onto triangle x double prime, y double prime, z double prime by a reflection in the, this is supposed to be in the line P, right? In the line P, right? So state the equation of the mirror line P. How do we state this equation? We need to figure out the location of a line which will be exactly midway between these two triangles. What is the distance between two corresponding points? It would be 1, 2, 3, 4, 5, 6. So 6 spaces in between. So half of 6 is, so let's draw a mirror line 3 centimeters away from this point here. That'll be 1, 2, 3. So that mirror line will be here. Let me draw it another friend. I'll put it in red. My mirror line is here. Right? Now, what is the value of x that this mirror line is passing exactly through? What value is this value here? Not seen it there, but that is 2. So the equation of this line, which is the mirror line, would actually be x is equal to 2. That is all the equation is. But they want us to draw the mirror line. So draw the mirror line for them, please. Right, so we on to January 2024, number 3. Right. So the diagram below shows 3 triangles P, Q, and R. Triangles Q and R are images of triangle P. So triangle P is your original object. After it undergoes a double transformation, right? So let me see what's going on here now. Describe fully the single transformation that maps triangle P onto triangle R, right? So what maps triangle P onto triangle R? So if you look at it, focus on it. Once the object and the image are facing the same way, looking the same way, like it didn't turn anywhere or didn't flip anywhere, that would be a slide. You all see that? This is a slide. So it's basically like if we track one point, let's track one point. We track in this point here. So it's like this point went 1, 2 to the right. Okay? So we're going to form a vector now. So that would be 2 to the right. Now, if it went to the left, it would have been -2. But it went 2 to the right, so it's +2. Then, up or down. If you go up, it's positive. If you go down, it's negative, right? So how many times did we go up to be by the same point here, this corresponding point? 1, 2, 3, 4. Because you went up, it would be +4. So I'm going to explain the translation now. So, describe fully the single transformation that maps triangle P onto R. The transformation, write this please, is by the vector. What was the vector? The vector is 2, 2 to the right, and then you went 4 up, right? 2 to the right would be positive 2, 4 up would be positive 4. Let's examine R onto Q. So what transformation maps R onto Q? It would be a reflection, right? But we need to establish where the mirror line is. So let's track two of the corresponding points. So let's look at this point to this point. How much centimeters apart are those 2 points? It would be 4 centimeters apart. Watch it. 1, 2, 3, 4. Halfway in between these 2 points would be which line? It would be this line here. Watch it. It would be this line coming on here. Right? Boom. So if you had to check it, right? So if you're checking 1, 2, and on this side you must have the same 1, 2. So what is the equation of this line? What is the value of x that this vertical line is passing through? 1. Not negative 1 at all. X is equal to 1. R onto Q. So the transformation, a reflection. Now, when you're writing reflection, my children, you don't put on the line, you don't put through the line, you put in the line. In the line, x is equal to 1, right? This is June 2023, number 3. The diagram below shows a trapezium A drawn on a square grid, right? So you have your trapezium A here. On the diagram above, draw the image of A after it undergoes a reflection in the line x is equal to -1. Label this image A prime. This little thing up here means prime, or you can say A complement, right? So we go in. I am first going to draw that line. X is equal to -1. So let me go. I'll go and draw it in red. X is equal to -1 will be a line running vertically and passing through -1. Proper? Right? You could go straight down or you could just stop there. Doesn't matter. This will be x is equal to -1. So if I'm reflecting, and I'm flipping it, so how it's looking on that side is supposed to look the other way on the next side, right? So let's track our point. So we go in 1, 2, right? So we come in here now, 1, 2. So this coordinate down here, -3, 2 would be here, right? Please do not use this as a mirror line. That's a common mistake students do. You know what they do? They go 1, 2, 3, and then on the side they go 1, 2, 3. That's wrong, right? So we go in now. I tell students once you reflect 1 point, you can build the rest of the diagram of that 1 point, you know. So watch it. You know this other point here is 2 centimeters, but it will be going in that direction. So you go 1, 2, boom. Then you know you're going 2 up now. 1, 2, bow. Then you're coming back 1 centimeter this way, bow. So let me build it. Boom. Bang. 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 And what is it to label this? Proper. So now they want us to translate the original object here, which is A, with the vector 4, -7, and label that image A double prime. So I'm going to write the vector here. The vector is 4, -7. I told you all something when we did the question before. If you're moving, the top number represents movement to the left or to the right. If you're going to the right, it's positive movement. If you're going to the left, it is negative movement. If you're going up, which is this here, this number represents movement up or down. If you're going up, it would be positive. If you're going down, it would be negative, right? It would be. So if you have a vector xy, that represents movement. So I'm going to put if x is negative, we move into the left. If x is positive, we move into the right high. Right, so your vector, the vector xy represents movement, right? Now, if x is negative, we move to the left, and positive, we move to the right. If y is negative, we move down, and positive, we move up. Okay? So, we have positive x and negative y. So that means the original object here, A, moves 4 to the right, and then 7 up or down? Down. It's -7. Once it's negative, you're moving down. I check in one coordinate, and I show you all how I'm going to build it off of that one coordinate. So we go in 4. 1, 2, 3, 4. Same spot where we end up with the reflection. Then we go in 7 down. 1, 2, 3, 4, 5, 6, 7. I gonna build the image off of that one coordinate. So I want you all to understand something. When you're sliding, is my object going to be shifting anyway or flipping anyway or going to look the same way? Going to look the same way. So if this is the coordinate in this corner here, it means the other coordinate will be 2 to the left. So that other coordinate will be here. Everybody good there? And then we go in 2 up. 1, 2. Boom. And then we go in 1 to the right. So let me build it. Right, what is it to label this one? A double prime. Double prime. So this is June 2024. The diagram below shows a shape T and its image Q. Original shape object image, right? After a transformation. Describe fully the single transformation that maps shape T onto shape Q. So if you look carefully, it looks like a flip, but some of you might be able to gauge where it is flipping, right? But there is a line that we call y is equal to x, right? That line is going to be right in the middle here. Right? Boom, bang, boom, bang, bang. Right? This line here is actually the line y is equal to x, right? Let me put that here. I'm going to label it y is equal to x. So look at it here. This coordinate here is half diagonally, half of a box away, and then the other one is half of the box away. You all seen that? Each coordinate is on the other side, so it flips. So this here would be the actual single transformation. So the transformation that, well, let's put the transformation is a reflection in the line y is equal to x. Above, draw the image of shape T after it undergoes a translation by vector -1, 6. Label that image M. So which one is the one we translating? We translating the object, which is T, right? So we go in, I'm going to write the vector here. It's -1 and 6. I told you all, if it's negative, what does it mean? It means you move into the left or to the right? Left. So you move 1 to the left, and if it's positive 6, we going up or down? Up. 1 to the left, 6 up. Track one coordinate and then build it off of that one coordinate. So we're going 1 to the left because the 1 is negative, right? And then you go 6 up because it's positive. 1, 2, 3, 4, 5, 6. So this is where this coordinate would be. If it is a slider, that means that it come like a pushing a car. So you push it so, and then you slide it up. So it would look the same way. So this other coordinate here is 3 centimeters to the right. So this one will be here. Everybody agrees? Then we go in 2 up. 1, 2 up. Then we go in 1 to the left. And we can build it there. You all see how simple? So we go in 1, 2. I don't know why that arrow come there. 3, and 4. Proper. And what is it to label it? M.